Good morning. Today's quote is you miss 100% of the shots you don't take. You miss 100% of the shots you don't take. Today's word is epoch, an event or a time marked by an event that begins a new period or development, a memorable event or date. Today we are going to start new topic, linear programming. Now, when two expressions are connected by the equality symbol, the statement is called as an equation. Okay. So I can say that A equal to B. It is an equation. Suppose A is not equal to B. Then there are two possibilities. If A and B are real numbers, then either A is greater than B or A is less than B. So greater than and less than are called as inequations. So I can say that suppose X and Y are any two real numbers. Now when I say any two real numbers, by that I mean positive, negative or zero. Then X is said to be greater than Y. Then X is said to be greater than Y if X minus Y is positive. I hope you are getting this. X minus Y is positive. Positive means greater than 0. And X is said to be less than Y when X minus Y is negative. Right? Now, what is linear equation? An equation involving the variables of the first degree is known as linear equation. See, you have to take literal meaning. The graph, the equation whose graph is a line is a linear equation. For example, y equal to 11, then 2x minus y equal to 7. All these are linear equations. A linear equation of the type ax plus by plus c equal to 0 represents a straight line where a, b, c are real numbers and a and b cannot be 0 at the same time. I repeat this, ax plus by plus c equal to 0 represents a straight line. A, B, C, they belong to set of real numbers and a and b cannot be 0 at the same time. The solution set of a linear equation with two variables is the set of all points on the line. That is, solution set of ax plus by plus c equal to 0 is given by, using set notation, I can say all ordered pairs x1, y1 such that ax1 plus by1 plus c equal to 0. Now, the next part is important and interesting. The line represented by linear equation divides the plane in three disjoint parts. I repeat this. The line represented by linear equation divides the plane in three disjoint parts. The points lying on the line and two half planes on either side, we usually call them as H1 and H2, which are represented by what? One will be represented by ax plus by plus c less than 0 and other will be represented by ax plus by plus c greater than 0. Is that clear? Now, we discuss linear inequations in two variables. See, today we won't be able to solve linear programming problems. Initially, we have to discuss how to draw the graph of linear inequations. Then we have to consider system of linear equations. That is, we will be considering three or rather two or more than two linear inequations and we'll try to find common solution. Now the relations ax plus by less than c or ax plus by less than or equal to c, ax plus by greater than c or ax plus by greater than or equal to c, where a, b, c are real constants and a and b cannot be 0 at the same time, are called linear inequations in two variables x and y. For example, x minus 7y less than or equal to 11, minus x plus 11y greater than or equal to 3. These are the examples of linear inequations in two variables. Now, what can you say about solution of linear inequations in two variables? If a value alpha of x and value beta of y are such that alpha x, in fact, not alpha x, when I say alpha is the solution, I should say a alpha, okay, plus b beta, because alpha and beta are the values of x and y, less than c, okay, then the ordered pair alpha beta is said to satisfy the inequation ax plus by less than c, and alpha beta is called a solution of the inequation ax plus by less than c. The set of all solutions of the inequation is an infinite set. For example, I can give an example. See, this is the graph. This is y-axis. This is x-axis. This is the graph of x equal to 5. Okay. So if a point lies on this line, x coordinate of every point is what? Is exactly equal to 5. If point doesn't lie on the line, then x is either greater than 5 or less than 5. See here, I want to tell you that in case of inequation, there are infinitely many solutions. Suppose x is less than 5. Now line doesn't pass through origin. So why not to verify whether origin is the solution or not? What are the coordinates of origin? 0, 0. Is 0 less than 5? Yes. So this is the solution of which inequation? X less than 5. Suppose this is the point, say 2.5 comma 0. Is 2.5 less than 0? Yes. So all points to the left of this line is part of the solution. That is why we say that the set of all solutions of the inequation is an infinite set. Let S be a set of points and A and B be any two distinct points of S if the line segment joining, listen to me carefully, if the line segment joining the points A and B lies wholly in S, then the set S is called a convex set. We note that segment AB for all pairs of distinct points A and B of the set S is to lie wholly in the set S. If there exists at least one pair of points, say C and D of S, such that segment CD does not lie wholly in the set S, then the set S is not a convex set. Now here you can see that the polygonal regions S1 and S2 are convex sets, but the region S3 is not a convex set. Note that convex sets may be bounded or unbounded. Here S1 and S2 are bounded, but here you will notice that this is an unbounded convex set. Okay, so this is about convex set. Now we will discuss graphical representation of linear inequation. We will start with simple equations like x equal to a, x equal to rather y equal to b. Then we will consider line through origin like ax plus by less than 0, and then general inequation rather ax plus by plus c less than 0 or greater than 0, and then we will consider two inequations at the same time. Okay, but I think we will consider rather we will start solving some from the exercise. Before that, let me ask a query. Just a minute. Now we discuss graphical representation of, I will consider particular example, say x less than or equal to 2 and x greater than or equal to 2. Okay. So first we draw a line corresponding to the equation. In x less than or equal to 2 is an inequation. What is the equation corresponding to this inequation? X equal to 2. So first we draw the line whose equation is x equal to 2. As I said, this line divides the plane into 3 disjoint sets of points. Set of all points which lie on the line. If a point lies on the line, then what happens? X coordinate of every point on that line is 2, right? And which are the other two disjoint sets? Half plane h1, I can call this as h1, this as h2. If line does not pass through origin, I can say that this is origin side and this is non-origin side. Clearly, if a point doesn't lie on the line, then it lies either in half plane h1 or half plane h2. Now, which plane is the graph of the solution set? How to decide that? As line is not passing through origin, I will consider 0, 0. Check whether 0, 0, suppose we are considering this one. Check whether 0, 0 satisfy x less than 2. Is 0 less than 2? Yes. And therefore, H1 is the graph of the solution set. Now, how to draw the graph of the solution set? For that, you have to use the arrows, right? Note that arrows, they initiate from the line. Why? Because we are not drawing graph of an inequation x less than 2. It is less than or equal to 2. And therefore, every point on the line x equal to 2 is part of the solution. I hope this is clear to you. And similarly, what about graph of x greater than or equal to 2? For that, I can say that this is the graph. Take any point. Suppose this point, say 4, 0. Is 4 greater than 2? Yes. So this is the graph of the solution set of which inequation? X greater than or equal to 2. Note that arrows, they originate from the line itself, because it is not only x greater than 2, it is greater than or equal to 2. So any point on the line is part of the solution. Now I will consider y less than -3. See, I'm not taking y less than or equal to -3. Working rule is simple. First we draw, or rather first we consider an equation corresponding to an inequation. What is equation corresponding to the inequation? It is y equal to -3. I hope you know how to draw the graph of y equal to -3. Yes, this is y equal to -3. Okay. Now, this line divides the plane in 3 disjoint sets of points. Points on the line, points on origin side, say half plane h1, and non-origin side, half plane h2. Now, how to decide whether origin side or non-origin side is the graph of the solution set? Consider coordinates of origin. 0, 0. Is 0 less than -3? No, 0 is not less than -3. So origin is not satisfying the inequation. You may say, sir, why not to check this point? See, if origin doesn't satisfy, every point on the origin side will not satisfy. For your satisfaction, you may consider this point. Suppose you consider this, which is what? It is 1, 0. Okay. Same. Is 0 less than -3? No. Consider this point. Suppose this point is 0, -1. Is -1 less than -3? No. This clearly indicates that origin side is not the graph. Non-origin side is the graph. Yes. Observe that arrows are not originating from the line. Why? Because if you start drawing arrow from the line, that will mean y equal to -3. No, y is strictly less than -3. Actually, we will discuss this by considering examples from exercise 7.1. Okay. Number 1, solve graphically x greater than or equal to 0. Consider the line whose equation is x equal to 0. This represents the y-axis. To find the solution set, we have to check any point other than origin. Why? Because this line passes through origin. Let us check the point 1, 1. When x is 1, is x greater than 0? Yes. Now don't say, but it is not 0 at the same time. How can it be? Either it is exactly 0 or greater than 0. So for 1, 1, I can say that it lies in the required region. Therefore, the solution set is the y-axis and the right side of the y-axis, which is shaded in the figure. Now, why it is said that solution set is the y-axis? Because it is not just x greater than 0. It is x greater than or equal to 0. Yes. Now, instead of 1, 1, you could have taken a -1, 0. I'll explain with that also. -1, 0. Check. Is -1 greater than 0? No. This means the region which is to the left of y-axis is not the graph. So the region to the right of y-axis must be the graph. You may show arrows also, arrowheads. That stands for infinite region, but this is also correct. Actually, it is not restricted to this much region, because every point on y-axis and to the right of y-axis is the part of the graph. Okay. Now, which is the second? X less than or equal to 0. Consider the line whose equation is x equal to 0. This represents y-axis. To find the solution set, we have to check any point other than origin. Let us check the point 1, 1. For x is 1. Is 1 less than 0? No. So 1, 1 does not lie in the required region. Therefore, the solution set is the y-axis and the left side of the y-axis, which is shaded in the figure. Actually, I will suggest better you draw graph like this. This is correct. And okay, show arrows also. Even if you do not, you will get full marks. But I think when you draw graph like this, anybody will ask, what about points above this? What about points below this? They are also part of the solution. Now, which is the third one? Let me see. Third is y greater than or equal to 0. Fourth, less than or equal to 0. So we have started from the simplest inequations. Consider the line whose equation is y equal to 0. This represents the x-axis. To find the solution, we have to check any point other than origin. Let us check with 1, 1. For y equal to 1. Is 1 greater than 0? Yes. So 1, 1 lies in the required region. Therefore, the solution set is the x-axis and above the x-axis, which is shaded in the graph. You are supposed to draw this on graph paper actually, but these are very simple inequations. So I think for the first question or even second and third, you may draw the rough sketches on your regular notebook. But when we deal with 2 or more than 2 inequations, in that case, you have to use graph paper only. Consider the line whose equation is y equal to 0. This represents the x-axis. To find the solution, say we have to check any point other than origin. Say 1, 1. If you do not want 1, 1, you can take 11, 11 also. You may ask, can we take 1000, 1000? Yes, you can. But how to plot that point? For that, we'll have to mention the scale and so on. So why to take 1000, 1000? Take 1, 1, 2, 2, etc. Now, is 1 less than 0? No. So 1, 1 doesn't lie in the required region. Therefore, the solution set is the x-axis and below the x-axis, which is shaded in the graph. Okay. Now you will notice that this is system of inequations. Why? Because x greater than or equal to 0 and at the same time y greater than or equal to 0. Let me explain. Consider the lines whose equations are x equal to 0 and y equal to 0. These represent, not represents, come on. These represent the equations of y-axis and x-axis respectively, which divide the plane into 4 parts. Since x greater than or equal to 0, y greater than or equal to 0, the solution set, see the word, the solution set is in the first quadrant, which is shaded in the graph. I hope this is clear to you. If you want me to explain this in detail, I'll do that. Suppose x is greater than or equal to 0. Now for x coordinate to be positive, this is the graph of what? X greater than or equal to 0, right? Now y greater than or equal to 0. Y greater than or equal to 0 means either first quadrant or second quadrant. Now, when we say solution set, common solution, we have to consider the region with horizontal lines and vertical lines, right? Intersection of two graphs. So you will notice that this is the required region. See, at least I ask students to draw graph like this. This looks better also. This one. Okay. So it's a matter of practice. In exam, you need not show this part. You have to directly show the common solution. Now next one. Since x is less than or equal to 0 and y greater than or equal to 0, this happens in which quadrant? Second quadrant. But note that points on positive y-axis, negative x-axis and origin. Of course, origin lies on this axis. But origin, that is 0, 0. So 0 is neither negative nor positive. So I mentioned that. So this is the graph of the solution set. I hope this is clear to you. Now x is less than or equal to 0, y is less than or equal to 0. Is the solution set? Rather, the solution set is in which quadrant? Third quadrant, including origin, points on negative x-axis, points on negative y-axis. Now x greater than or equal to 0, y less than or equal to 0. The solution set is in the fourth quadrant. Okay, this is not difficult. Now we will consider lines passing through origin. This is interesting. Now I will explain this. 2x minus 3y greater than or equal to 0. (2x minus 3). What is that in the textbook? Greater than or equal to 0. Okay. So first we consider, or I can write this as x greater than or equal to 3/2. First we consider, I already explained this, equation corresponding to inequation, right? So x equal to 3 by 2. Now x equal to 3 by 2. See, you should be able to grasp this in just 2 or 3 seconds. If you think, oh, whether it is parallel to x-axis or y-axis, immediately you should come to know that x equal to 3 by 2 is a line which is parallel to which axis? Y-axis. So x equal to 3 by 2. Now listen to me. Did I say that line passes through origin? I'm sorry. 2x minus, it is not 2x minus 3y. It is 2x minus 3 greater than or equal to 0. I think initially I said that let us consider lines through origin. I'm sorry. Line is not passing through origin. Line is parallel to y-axis. Now, this line divides the plane in 3 parts. For all points on the line, x is exactly 3 by 2. If point does not lie on the line, then x is not 3 by 2. So it is either less than 3 by 2 or greater than 3 by 2. Now, simplest working rule, if line is not passing through origin, consider origin 0, 0. So put x equal to 0, y equal to 0. There is no y. Is 0 greater than 3 by 2? No. Is 0 equal to 3 by 2? No. This means origin and every point on the origin side is not the part of the graph. Okay. So don't waste time in drawing the graph, because see, to solve a linear programming problem, you hardly get 8 to 9 minutes. If you waste 2-3 minutes in this, you will require more than 20-25 minutes to solve that linear programming problem. Okay. So this is the graph of which inequation? X greater than or equal to 3 by 2. Now let us read this. Consider the line whose equation is 2x minus 3 equal to 0. I told the same thing. X equal to 3 by 2. This represents a line parallel to y-axis passing through which point? 3 by 2, 0. Draw the line x equal to 3 by 2. Okay. To find the solution set, we have to check the position of the origin 0, 0. When x is 0, is minus 3 greater than 0? No. So the coordinates of the origin do not satisfy the given inequation. So solution set consists of the line x equal to 3 by 2 and the non-origin side. You may also say to the right of that line. Yes, same thing. So non-origin side of the line which is shaded in the graph. So you are supposed to draw this much only. Say third example, first part, draw this. But I think instead of drawing like this, draw like this. Just 4 arrows, but note that at least there is 1 arrow in the 4th quadrant also. And observe that arrows originate from this line x equal to 3 by 2. Okay. Now next part is simple. Y equal to 5 by 2. See, this theory part will not be asked in the exam. I'm just explaining this. Nobody will ask you the procedure to draw the graph, or nobody will ask you the definition of convex set. No. In fact, you won't be asked to draw the graphs of these lines. We require this for solving linear programming problems. Now consider the line whose equation is y equal to 5 by 2. So we draw the line y equal to 5 by 2. Now check coordinates of origin 0, 0. So put y equal to 0. Is minus 5 greater than 0? No. This means origin side, that is Region below line is the origin side, is not the graph. Region above the line is graph of the solution set. So this is not at all difficult. This is for what? 2y minus 5 greater than or equal to 0. Third one is what? 3x plus 4 less than or equal to 0. Consider the line whose equation is 3x plus 4 equal to 0. See, I have already told you that first we have to consider an equation corresponding to the given equation. And that being a linear equation, its graph is a straight line. And as I said, that line divides the plane into two half planes, h1, h2. And we have to decide whether h1 is to be considered or h2 is to be considered. So x equal to minus 4 by 3. This is a line which is parallel to y-axis. Passing through which point? Passing through the point minus 4 by 3, 0. Right? So that line is drawn. To find the solution set, we have to check position of the origin 0, 0. So put x equal to 0. 0 plus 4, 4. Is 4 less than 0? No. Coordinates of the origin do not satisfy the given inequation. So the solution set consists of the line and non-origin side of the line. That is to the left of this line. Okay. So this is the graph. Fourth one. What is that? 5y plus 3 less than or equal to 0. So corresponding equation y equal to minus 3 by 5. Now this represents a line which is parallel to the x-axis, passing through which point? 0, minus 3 by 5. Again, same logic. First, draw the line. See whether coordinates of origin satisfy the inequation or not. Put y equal to 0. So 3, is 3 less than 0? No, 3 is greater than 0. So the coordinates of origin do not satisfy the given inequation. So the solution set consists of line y equal to minus 3 by 5 and the non-origin side of the line which is shaded in the graph. I repeat, in exam, you are supposed to draw the graph directly. No explanation is required, in the sense you are not supposed to write the explanation part. That's it. Okay, now we will start drawing the graph. Only first part is explained. X plus 2y less than or equal to 6. Consider the line. Let me explain first, because second, third and fourth you are supposed to solve. I won't solve that. Consider the line whose equation is x plus 2y equal to 6. See, every time you are supposed to draw the graph of an inequation, you have to consider corresponding equation. Even if it is x plus 2y less than 6, in that case also you have to say equation corresponding to the given inequation. The only thing is you have to replace that inequality sign by equal to sign. I hope this is clear to you. Now, how do we draw the graph of a linear equation? See, two distinct points determine a line. For safer side, you may consider 3 points, but if you are confident, then 2 points are sufficient. Usually what we do, we put y equal to 0 to get 1 point on x-axis. We put x equal to 0 to get another point on the y-axis. And of course, in LPP, we are interested in those corner points, in most of the cases, they are points of intersection of line and axis. So put y equal to 0, we get x equal to 6. So A60 is a point on the line. You may name this point as C, D, etc. But usually for the first line, we use AB, second CD, third EF, and so on. Now when x is 0, we get y equal to 3. So B03 is another point on the line. See, this is how graph is to be drawn. You are supposed to mention the scale on both axes. 1 centimeter is 1 unit. See, this is the final answer. First, this line is drawn. Okay, x plus 2y equal to 6. Now, listen to me carefully. This line is not passing through origin. So, either half plane H1. We will not call H1 because we will call it as origin side, or you may say below the line, same thing, origin side or non-origin side. We have to decide that. Okay. So the draw line AB joining these points. This line divides the plane into two parts, origin side, non-origin side. To find the solution set, we have to check the position of the origin with respect to the line. Coordinates of origin are 0, 0, right? So 0 plus 0, 0, 0 less than 6. We have to solve which inequation? See, less than 6. This means coordinates of origin, and therefore all points on origin side will satisfy the inequation, right? And that is why this is the graph. Observe this, that every point on the line is part of the solution. You will notice that first quadrant, second quadrant, third quadrant, fourth quadrant. So all points, in fact, some points in all the quadrants. What can you say about third quadrant? Yes, all points in the third quadrant, and this region in the first, this region in the second, and this region in the fourth quadrant is to be taken into consideration. I hope this is clear to you. Okay. See. Second, consider the line whose equation is 2x minus 5y equal to 10. See, this is the line. Okay. How to draw that? In fact, you may say, can we write this in double intercept form? X upon 5 plus y upon minus 2 equal to 1. So 5, 0, 0 minus 2. These points lie on the line. Now origin side or non-origin side? Put x equal to 0, y equal to 0. So 0 minus 0, 0. What is that in equation? Let me check. 2y, just a minute. What is that in equation? Okay, 2x minus 5y greater than or equal to 10. Is 0 greater than 10? No. So origin side is not the graph. Still, some students may think you have checked for origin, but what about these points? See, when I say origin, by that I mean all points on the origin side, that is all points above the line, cannot be the part of the solution. So points below the line, including points on the line. Why including? Because it is not 2x minus 5y greater than 10. It is 2x minus 5y greater than or equal to 10. I hope this is clear to you. See, you have to draw arrow here also, because these points, see this angle, infinite region, these infinitely many points are also part of the solution. Okay, so this is for 2x minus 5y greater than or equal to 10. Now third one. See, I will not explain this, I will not read this. Consider the line whose equation is 3x plus 2y equal to 0. The constant term is 0, therefore this line is passing through origin. So one point on the line is 0, 0. To find the another point, we can give any value of x and get the corresponding value of y. See, that doesn't mean that you should put x equal to 11 upon 7. Why? Because if you take x equal to 11 by 7, fine, we can find y. But that point we have to plot it on the graph paper. And that is why choose x equal to 2 so that y equal to minus 3, right? So 2 minus 3 is another point on the line. We need 2 points because 2 distinct points determine a line. So that so draw the line OA. To find the solution set, we cannot check 0, 0 because it already lies on the line. So we can check any other point which is not on the line. Let us check 1, 1. So put x equal to 1, y equal to 1. 3 plus 2, 5. Is 5 greater than 0? Yes, it is. 5 is greater than 0. So 1, 1. 1, 1 lies in which quadrant? First quadrant. So instead of saying first quadrant, I can say any point above the line. I can say this region below the line, and this is above the line. If you want to verify, you can. Suppose you choose this point 0, 3. So 3 into 0, 0. 2 into 3, 6. Is 6 greater than 0? Yes. Suppose you decide to select this point 2, 0. 6 greater than 0? Yes. Suppose you decide to select 3 minus 1. 3 into 3, 9. 2 into minus 1, minus 2, 7. 7 greater than 0? Yes. And therefore, this shaded region is the graph of the solution set of which inequation? 3x plus 2y greater than or equal to 0. So working rule is simple. If line passes through origin, any other point than origin is considered. In fact, they have taken 1, 1. I would not have taken 1, 1. I would have taken this point 1, 0 or 0, 1. Okay, but this is also correct. Then fourth one, consider the line whose equation is 5x minus 3y equal to 0. This also passes through origin. So origin is one of the points lying on the line. You have to choose one more point. Put x equal to 3, so y is 5. So A3, 5 is another point on the line. Draw line OA to find the solution set. We cannot check 0, 0 as it already lies on the line. We can check any other point which is not on the line. Let us check with 1 minus 1. Put x equal to 1, y equal to minus 1. So that gives me 8. Is 8 less than 0? No, 8 is greater than 0. And therefore, 1 minus 1 will not lie in the required region. Therefore, the required region is the upper side, which is shaded in the graph. See, in fact, I would not have considered that point. When we draw the line, I would have considered 1, 0. Check for 1, 0. 1, 0 means below the line. 5 minus 0, 5. 5 less than 0? No. So 1, 0 is not satisfying. So rather region above the line is the graph. I hope this is clear to you. Yes. Okay. Now, 2 inequations at a time. In LPP, in most of the sums, we have to consider 3 or more than 3 inequations at a time. I'll just explain the first part, then we will be solving second and third. In fact, you will be solving second and third. I repeat, in exam, you need not write explanation part. First one, 2x plus y greater than or equal to 2 and x minus y less than or equal to 1. You have to begin with, first we draw the lines AB and AC whose equations are 2x plus y equal to 2 and x minus y equal to 1 respectively. In fact, I would not have written AB and AC because just by observing this equation, rather these equations, how can we conclude that one point is common, right? And that is why, see, 2x plus y greater than or equal to 2 and x minus y less than or equal to 1. So I usually start with, first we draw the lines. I do not write the name, whose equations are respectively. And if I come to know that one point is in common, then I write AB and AC. Otherwise, AB and CD. Okay. See, line AB, this is the equation. Points, no, it should be point. Point on x-axis, A1, 0. Point on y-axis, 0, 2. See, in some exceptional case, we do not consider point on any of the two axes. I'll explain that. This is the sign. Now, region, that we come to know only after drawing the graph. Okay. So, what about x minus y? I'm sorry, 2x plus y greater than or equal to 2. Consider 0, 0. Is 0 greater than 2? No. 0 is less than 2. And therefore, for this line, you have to consider region above origin. Rather, just a minute, consider this. Yes, for this line, coordinates of origin do not satisfy the inequation. So non-origin side, this is the graph. But at the same time, another inequation is x minus y less than or equal to 1. Put x equal to 0, y equal to 0. Is 0 less than 1? Yes, it is. So for the line x minus y equal to 1, you have to consider origin side, that is above the line. So this is the common region. Okay. The solution set of the given system of inequalities is shaded in the graph. Now you will ask me, how come we directly draw the common region? So initially, you may use horizontal lines to draw the graph of first inequation, vertical lines for the second, and then you may say that common region means the region in which, or the region which is shaded by horizontal lines and vertical lines is the graph of the solution set. That is also correct. But after sufficient practice, see, above this line, so this is the region. Are we supposed to consider points on these arrows? Yes, we have to consider, because observe the inequations. Greater than or equal to, less than or equal to. Exercise 7.1, fifth question, solve graphically. Second part, x minus y less than or equal to 2 and x plus 2y less than or equal to 8. First, we consider equations corresponding to inequations, x minus y equal to 2. See, if possible, take 1 point on x-axis, 1 point on y-axis. So that gives you an idea whether you have to change the scale or not. Now, why I'm saying if possible, if equation is say 3x minus y equal to 2, then in that case, I will not say put y equal to 0, because x will be 2 by 3. I won't say 2 by 3 cannot be plotted, but again, you will have to select the scale accordingly. But in 99% of the cases, take 1 point on x-axis. Rather, this is possible. Take 1 point on x-axis and 1 on y-axis. So when x equal to 0, y is minus 2, y is 0, x is 2. So the points 2, 0, 0 minus 2 lie on the line. Here, the points 8, 0, 0, 4 lie on the line. So these are the lines. Okay. You have to do these many things. Basically, name the lines. Then, if possible, write the coordinates of these points of intersection of axis and the line. And most importantly, you have to write the equation of the line. Okay. Now, next important task is which region is to be shaded. Now consider first inequation, x minus y less than or equal to 2. Basically, both lines are not passing through origin. So check with 0, 0. 0 minus 0, 0. Is 0 less than 2? Yes. And therefore, we have to consider, let me explain, origin side of this line. What about second inequation? Check for 0, 0. Is 0 less than 8? Yes. So we have to consider origin side of CD also. I repeat, origin side of line AB and origin side of line CD. So you are expected to shade which region? This region. I'm sorry, this no part below this line. Yes. I expect you to draw the arrows also. Okay. Yes. This is the graph of the solution set. So below that, you have to write the solution set of the given system of inequalities is shaded in the graph. While solving LPP problems, you have to name this point also, but in this case, it is not required. Okay, so here I will write the solution set of given system of inequations is shaded in graph. Of course, this will not be asked in exam. We need this while solving linear programming problem. So that's it for today.